Well, I think the question is,
no, that for short time. Maybe not for the
steady state it is.
All these values are only for one time.
no. Values.
and what that means that power is dissipated. Well, I think at least our simulation is complete. This is not a dissipative power. These components here, because this is a DC source here, so I cannot have a dissipative power. We are looking at the current here, input power, looking at the input power, right? So the only power which matters really is this power. Now what is this power here is, you have got, so my current, ideal current is like this. But the waveform of the current is switching like this. Right? Something like, let's say, this is your waveform of the current. Right? So if you look at the slide, that's how your input current looks like. Okay, so we are taking an FFT of this one, and the only power which is being dissipated is the DC component. This component is, if I put a frequency, if I put a capacitor, so what will happen is, if I put a capacitor here, the only power which will go from here is 48 watts. Everything else is going from here. Right? So it's only providing the filter component. It's slowly getting charged here and then providing the filter components out to the inverter when the inverter needs a 20 kilohertz. So effectively, my current in this branch goes to DC when I put this capacitor here. And yes, 49 watts of power is being drawn from the capacitor, but it is at high frequency, and this capacitor is getting that power slowly when it gets charged. That is, so all the components basically you have is strictly because that component of power, the inverter still needs that power, right? But that power is a circulating power. It is being drawn from one component, being given to other component, but it is not dissipating. You have got, of course, the device losses and the diode losses and all that become significant with this kind of power, but there is no actual power. There is no output power because of that. Okay, let's look at our results.
Just one question about this waveform. Are these spikes, are they real, or are they actually observed in machines, or are they just simulation artifacts?
So this one, I think, could be related to reverse recovery of some of the diodes. I'm not sure. We can check.
Plot the diode current.
Pardon me?
Plot the diode current.
Yeah, we could plot the diode current. Well, see, in the real time, you really have got a big filter capacitor bank. So you really are not here. We don't have any capacitor bank. We're actually looking at the real waveform. But definitely you can plot the diode current and see what affects. Because anytime the diode comes into play and you have a reverse recovery, it's going to show on your input current, and that's a bad part of it. And so that's where, when you're doing PWM all the time, the diode